Okay, we have a MacBook Pro. Uh, it's an A1502, and the description says no power. So, as usual, the first thing we want to do is we want to take out the back cover of the device. We're using a Pentalobe P5 screwdriver. I have one of the screws missing. Okay, so this is a 2015 A1502. One of the ways you can confirm that it is in the 2015 is you look at the RAM aspect, the RAM cover here. That is particular to 2015, and also the trackpad cable going over the battery. That is also particular to 2015. The 2014 and 2013 A1502 trackpad cable will go below the trackpad. For the 2015 A1502, the trackpad cable will go over the trackpad, and also so you can see the trackpad design for the 2015 is completely different from that of the 2013 2014. So the 2013-2014 logic board will fit in the same shell as will fit in the same shell. However, the 2015 logic board will not fit in the 2013-2014 shell. And also the 2015 does have the haptic feedback in terms of the trackpad design. The 2013-2014 doesn't have that. So first thing first we want to do, we want to disconnect our battery, give the board a bit of a dusting, then we can get to understand what is the state of the board, where are we, and what needs to be done to get our device up and running. Okay, let's connect our charger and see what we have. Charger is connected. We have charger communication. And also 2015s did not, when you connect a charger, even though if this was a 2013-14 and the device had no issue, when you connect the charger, the fan should start. So, but 2015s, the fan only starts after the CPU has become really hot. So let's see what we have on our basic power rails. Let's open up the board view. So it's 820-29 4924. That's the board number 4924. Let's open up our board view. Here it is, 4924. Okay, so let us see what we have on our PPDC in as well as what we have on our PP bus. So PPDC in we can check here. PPDC in we can check our PPDC in voltage here, which is our PPDC in. Let's see if we have our PPDC in. Okay, let's see what we have on our PPDC in. Switch our multimeter to voltage mode. Okay, PPDCN is present, and usually, so even though it says here, even though it says 18.5 volt, so the PPDCN is going to be dependent on the output of the charger that you have. So we have 18.5, yeah, that 18.5, even though it says 18.5, we're getting 16 point something volt. That is the charger that we have. So that's the output of what we have. Now let's see what we have on our PP bus. We can get a PP bus voltage. We can get our PP bus voltage from here, from R 705. Let's see what we have in our PP bus. PP bus is 12.63. Let's see if we have haptic feedback before we continue. Okay, we don't. I mean, if you were in SO state, so we'll be having haptic feedback. Now let's see if we are in SO by measuring by this inductor here, L7520. So whenever you see L, that is a way of referring to an inductor. Let's see, we're supposed to have 5 volt there, but that will be present if you are in SO. Let's see what you have there, and that is not present. So what we want to do is we definitely not in SO. We want to take out the logic board and get to understand what it's really happening. So we have confirmed that we have our PPDC in, we have our PP bus. So if we have our PP bus at 12.6, that tells us that definitely our PP3B42 is present, and it also tells us that we don't have a, I mean, we definitely do not have issue with our PPDC in because we have already confirmed that PP bus is present, PP3B42 is present, because if our PP3B42 was not present, our PP bus would not be sitting at 12.6. Because in order for that to happen, the SMC has to be running. If PP3B42 wasn't running, the SMC would not be sitting at 12, would not be engaging PP bus to set it to 12.6. So the next thing we want to do is we want to confirm if our source rail is present. So we want to confirm if other rails on the board are present, and then get an idea of exactly why we are not going into SO. Okay, board is out. Okay, that is sign that there was liquid on the board. Okay, let's see what's been affected. Okay, okay, so you guys can see that section of the board. This section of the board, I'm not really worried. Why? Because this is a section. This is your battery charger IC, and this section, because we have our PP bus complete, I'm not really worried about this section. However, the section I'm worried about is this section. So let us see what is in this section. So we have. So let's see. Let's at the same time let us open our schematic for 4924. Let's open our schematic for 4924. Okay, let's see what. And so the first thing first, let's see what do we have here? What is damaged? Flip to the other side. So this is our 5 volt 3 volt regulator. So U5660 is what is affected here. Let's see, is that it? Okay, you can see, and so this area, also this is affected. This area is affected. So basically this area, which is this area like this. This is our focus. This we're not really worried because we do have our focus. So this area here is what we're worried about. So let's see what it is that we have in that area. We have that. We have that. Okay. PM sleep. Okay. SMC. Okay. Now that is important. So what we want to do is we want to, let's see what is this, and then this, and this, and then this, and then this. Okay, let us measure. Let's connect our charger and see if we have our 5 volts from E75 705 7501. Let's see if we have 5 volts there. Um, okay, three. Uh, okay, we're supposed to have 5 volt here. However, we're getting 3 volt. Okay, and also the chip itself seems to have a little bit on the other side. Okay, so that area will be our center of focus. The first thing we want to do is we want to take out. Uh, okay, let's get to clean that. Let's see. Okay, let's clean that section. No, wait. Look, I get soap. Soap. Yeah. Yeah, just soap. I wanna get to have an idea of exactly what and what has is affected. So I'm trying to clean it up. Like I said, I'm not worried about the section yet. Uh, we will address that, but right now we want to get the board to start. So this section here is what needs to be addressed to get the board to power to go into SO state. So I'm doing this to get an idea because I'm trying to clean that section to get an idea of what needs to be, what's affected and what not. So this way we can see exactly um, what needs to be replaced and what was just partially stained by the corrosion. Okay, so clean that. Zone 3. I'll call you later. You see what? Not the driver. I mean, from when you get it from the app itself, then because when it's outside, you will get a message from the app. Okay, now we can see exactly what needs to be replaced. Yeah. So the next thing we want to do is we want to apply our flux and replace the components that are. Okay, now we need to clean it again. Um, you see, uh, some of these points that it's going to be listed as TP on the board, those points are they are more of uh, uh, like a bridge between one point and another. So when you have a break, for example, like this one here, that seemed like to me like a break. So here, this is it's broken up. We'll have to join that pad. It's seems to be broken up. Yeah, we need to make sure that pad is joined. We'll find out what that is shortly. Okay, let's see what that is. So if you find a section like that looking that way, what you want to do is you want to be sure that you do not have a break as a result of that. You don't have a break in line, otherwise you'll find yourself replacing all of the components that appear to be faulty or messed up, but still you don't have a working circuitry. Okay, so let's see what is that. Let's see what that part is that's broken off. Uh, let's move this a little closer. So we have that. Okay, and should have okay. Let's see this. So let's see that. So let's see this. R5440, we should have a continuity between that pin and this pin. Let's see if we have that. So it's between here and the cap, this cap here. C7500. Let's see if we have it. Okay. Now that is the point that's broken. So this point here. So it says the point here. This is it says that separation that has basically separated this and this, which is yeah, which is important. Let us put that in place real quick. Now we are already trying to we're already in the process of repairing our circuitry now. Just a little bit of flux. So again, what was it? Alex. Is it sending the device that he just the one that just came in now? Okay, cool. Okay, now let's see if that bridge has been joined. Okay, let's try again. Okay, yeah, that's it. So that has been resolved. Now let's get a donor board to get a where we'll be getting our components from. Getting our components from here. Now, if we look, so there was a break there that has been fixed. The next thing we want to see is so, or the next thing is this part here. We want to know what that part is. This part here, because that seemed to be also washed out. Let's get another. Okay, let's see what that is. I'm talking about this part here. You see on here, it's also washed out. Let's see what that is, which is this one. Okay, let's see, where does it go? Okay, let's see if we just have continuity. Let's see if we have continuity there. Okay, that's fine. We don't have a problem on that side. The next thing we want to check. Okay, that's fine. Let's just now redo the circuitry and should be good to go. So like I said, right now we're only worried about the circuitry. After that is done, then we can go over our battery charger circuitry. Right now we don't really. The middle pin, let's see, the middle pin of U5660, this one, uh, yeah, okay, that seems to be off. See what you can do there. Okay. So I mentioned to you guys how important it is to make sure you invest in your donor boards, because that is your bank for components. Um, that's where you get your components from, easy, instead of you having to imagine if I have to order this one component or the other component or that other component before this repair can be complete. It will slow down your output, and yeah, you don't really want that. Okay, I'm still gonna go over pin 5 of V56 60, but first and first, let me put back our R5660 and C5660. Oh, by the way, this is our current sensing circuitry. So let's put that back. Okay, so that is put in place. The next thing we want to worry about is the pin 5. Yeah, let's see what we have on our pin 5. Let's see. We want to make sure we have continuity. We want to make sure we have continuity between pin 5 and pin 4 of our R5400. Let's measure that. If we don't have continuity, we may have to work around that as well. Okay, we do have continuity, but I just need to confirm something to be sure. Hmm. Okay. Let's see. Okay, we do have continuity. So now what we want to do is we want to see if we now have 5 volts. So let's quickly head over to E7501. You guys will have an understanding of why that is important. E7501, where it's schematic for 1502. Okay, so E7501. It's very sleepy. E7501. Okay, this is our E7501. Now it says 5 volt and 3.3 volt power supply. Still nothing for you. Okay, so this is a 5 volt and 3.3 volt power supply section of the board, so which is G7501. So if we do not have, if this section is not active, obviously the 5 volt and the 3 volt rail of the board is very crucial, without which you will not get your board to go into SO state, which is your board will not power on if you don't have that rail. Hmm? Okay. Okay. Uh, so all of the components that we need to transfer on this section are done. The next thing we want to do is we want to see if our board is starting now. Like I said, we don't need this section of the board for the board to start, because the voltages that require from this section of the board, the charger and the charger battery IC, they are present, so we're not really worried about that. Yes, we're still going to clean that out, but right now we want to get the machine started. So now let's see what we have. Connect our charger. Okay, we have other communication. Now let's see if we have 5 volt on our U 7501. We're splitting to our 5 volt here, which we were not having before. What? What? Okay, let's see. Okay, now we have the 5 volt. That's good. Let's see if we have an SO rail, which will tell us that our machine is starting. Yes, that is a 5. That is an SO rail. So now let's see if we have an ample logo. Before we address that section of the board, the other section of the board that I said we didn't really need for the machine to start. Connect our screen only. Just the screen alone, it's fine. Let me see if we have Apple logo. We can as well connect our speaker. So the A1502 does not require any form of I/O board cable to activate the speakers, unlike the MacBook Air that requires the I/O board cable to activate the speakers. Without I/O board cable being connected, the speakers will not be active. For the A1502s, there is no I/O board cable activation for the speakers. So just you can just connect one of the speakers and see if we get a chime. And also, it doesn't really matter if we get a chime or not. So sometimes you may not actually get a chime unless you kind of do a pyramid set. And also sometimes people can as well turn off the startup sound. So let's see. Okay, that's a chime, and that's a light on the screen, and that is an Apple logo. So that is not all. Yes, the actual repair is done. Machine is it's a low power, that is done. So the next thing we want to do now is we want to clean out this section where we worked, and also we want to address that other section where we have liquid. So that is, like I said, that is not pertinent to our repair, but we need to clean that. We can't just leave it in, you know, can't just leave it that way. Let's clean that section, and uh, and that will be it. And that will be the end of our repair. So you guys basically saw how, so repairs like this, when you are working on such, you have to be very careful when it comes to the TP points. So I'm talking about, when I mean TP, I'm talking about points like this. It says test pads. So these are very important. So I'll give you an example. So if you look at this, for example, so C7503 connects to pin 22 of U7501. Now the TP here, this is going to be the test part. And also, uh, if for any reason you have liquid in this section and then this pad severs from the board. So what will happen is there will be a break between pin 22 and pin 1 of C7503. So if you have to replace U7501, for example, and also replace C7503, but then not address this section of the board, this and this will work independent, whereas it's supposed to work in unison. So what that will mean is your circuitry will not function the way it's intended. So after you replace this and that, you have to now measure for continuity to be sure that pin 1 it's connected to your pin 22. So if you have a break here, then you will have you will have a break between pin 22 and pin 21. So which is what we did, what we had to ensure here, and then we had to put like a solder block to cover that section. So when you have liquid damage, when you're working on a liquid damage device, that is something you really need to look out for. Otherwise, you will replace all of the components that seem faulty or affected, but still your machine is not going to function. That is all. So we have some components that are not looking good around the ISL. What we want to do is we want to, these components are not faulty right now, but let's replace them just to, to prevent them failing in the future. Okay, let's clean that section and then replace clean the section. A bit of solder in that section as well. We have three machines that are urgent. This is the first one of them. So after this one, we'll quickly grab the next one and then the next one. Okay, get our donor board, get the components that we need real quick, and we're good to go. Are you seeing this or you're seeing my hand? Because I see the videos that's in the chat. So the whole point of you making the videos is so that you can actually capture the moment. But I see even with that, you're capturing my hands when you're supposed to capture. That's what's happening on the board. No, no, no. You can if you want to actually. He's gonna help you. So that's the whole point of you having to. I mean, that should be the advantage of something that you do and something that is just sitting there. Because if you're just sitting there, obviously there's no movement. But if you're there, you're supposed to be able to move. The owner said that's the password. Even inside, still not going through. Yeah, but it's weird. I mean, if it's not changed, how is it not working? Yeah. Okay. Oh, okay, 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 okay. Yeah. So cleaning the board with the toothpaste. How do you do it? With what? With the toothpaste. You can, but that's not the final project. You have to still clean it further. Yeah. Okay. So that's it. Just a little bit, and that's it. We have a working board. This is gonna go to. You can just wipe this just a little bit. This. Yeah, it's good. So this will go to the test. Go through the testing phase, and that's it, guys. I'll see you guys in the next video.